Okay, so good afternoon, guys. So yeah, continuing in our Android training. I think last week we looked at room database and then got to implement that in our notebook application, right? But today we're going to just take a detour. Just going to step back a bit and we're going to look into custom views, right? And what it's about, and then we're going to be creating that UI you're seeing there, a fan control application and with some functionalities actually, right? But how can we actually create that view? Of course, there's no image view you have that will actually do this, right? And so we're actually going to be learning how to create a custom what view. So basically the app is just going to display what we have here, just like it is just a circular UI, right? That kind of just looks like your normal fan control, right? Just like a physical fan control. So you have a setting to turn it off, you have to put it to one, two. So probably off, we can say off should be zero. One should be, let's say, low, two, medium, three, high. So we're going to do it in such a way that when the user taps on the view, this indicator, which is this small black dot here, right? So we can just call it a selection indicator, right? To just move to the next position. So from zero to one to two to three, and then back to zero. And also we can do something like if the selection like is from one or higher, that is one or two or three, the background color of this circular guy should actually what change from one color to another. Okay, so that's basically what we're going to do. That's just like an overview of what we're going to be doing, right? And yeah, so what are we going to cover? So we'll get to see how to extend the view class to be able to create your custom view. Okay, we'll see how we're going to extend the view class to create your custom view. Because to actually create a custom view, you're basically extending an existing view subclass, right? Which could either be a button or an edit text, right? Or you're actually creating your own subclass, of course, and that means you're extending the view class directly. So that's basically what we're going to cover. Also learn how to draw a custom view that is circular in shape, which based on the app I showed you. We'll learn how to use listeners to handle user interaction with our custom view, and of course, how to use a custom view in your layout, right? So let's just understand a few things about the custom view, right? So basically, views, like are the basic building blocks of your application's UI, right? So the view class provides many subclasses, right? And those many of them are referred to as UI widgets, right? That helps you to kind of build your UI. Okay, so UI building blocks, which is views, right? Like your button, your text views, they are all subclasses that extend the view class. Okay, so to actually save time and development, what we basically do is that we extend one of these view subclasses, right? So imagine if you wanted to create every time you want to create a text view, you have to create every property of that text view. You have to declare all the properties first, create the text view class before you now create an instance to make use of it, right? So Android has already done that for us. So all we just basically do is just extend it, right? So the custom view basically inherits the look and behavior of its what parent, right? And you can also override the behavior or any aspect of the appearance that you actually want to change. So, for example, here, right, you see this edit text, right? We can extend edit text to create a custom view. So, sorry, we can extend edit text to create a custom what view. So the view will just act as an edit text word view, but you could also customize it to show, for example, this X here, right? To show an X button that will clear the text from your text entry words field, right? So that's basically how the whole custom view stuff actually what works, right? So you can extend any view subclass like your edit text to get a custom view. So, and then you just pick the one that's closest to what you want to accomplish, right? And then you can use that custom view like any other view, right? Any other view subclass. You can use that custom view in one or more, of your layouts, right? As an XML element that has attributes. Okay. So now the thing is, if you wanted to create your custom view from scratch, right? To create it from scratch, you have to extend the view class itself, right? So your code will now override, the view methods to define your own view's appearance and what functionality. So the key to creating your own custom view is that you are responsible for drawing the entire UI elements of any size and shape to the screen. You're responsible for doing that. So, but if you subclass an existing view like your button, that class, the button class already handles that drawing for you, right? We'll learn, I'll show you how to actually draw views. We'll learn about that, okay? So to create your custom view, there are generic steps you can actually you should take. First of all, you create your custom view class that extends view, or it extends a view's subclass. So button is a subclass of view. Edit text also is a subclass of the word view. So it's either of that. You create a custom view class with whatever name that extends the view or extends a view subclass like your button or edit text. Now, another step is, if you're extending an existing view, let's say you're extending an edit text or a button, you override only the behavior or aspects of the appearance that you want to change. You don't override everything, just the methods you want to change or the certain parts of the appearance that you want to adjust. But if you're extending the view class, you have to drop that your custom view shape. You have to control its appearance by overriding view methods such as the onDraw and onMeasure in that your new class. Will actually do all these things, right? So because you're actually just doing it, you're basically building your view from scratch. Then, of course, you can use the custom view class as a UI widget in your XML, your activities XML layout or fragments, whichever one, right? You can also define custom views for different. Okay, so please, if there's any point you can't hear me, just let me know. Right. I think I'm having a bit of network challenge. Okay. So yeah, let me just share my Android Studio. So I've already created a project that I call remote controller, right? So it is just basic. I haven't done anything special, right? So we just have an empty, empty activity here. So we're going to play around with it. So the very first thing, right, is we want to create a custom what view, right? The very first thing is to create a custom what view. Okay. So let's just do a simple UI, right? Let's do a simple UI. Just here I'm just going to, so this text, let me just call it this. Okay. Give it an ID. Let's call it mm, let's just call it label, right? And I'm just going to take out some constraints like the bottom constraints. Yeah, I don't want it to be constrained to the bottom, right? I'm going to give a top margin of say 24 dp. Remember, best practice is your dimensions. I'm just going to do it once or twice. Just going to do it once or twice, then I won't do that again. But you should extract your dimension resource, your string resource, you make sure to actually do that, right? Okay, so I top margin. So for start, other- okay, please confirm you can hear me.
Yes, I can. I can hear you.
So just doing some, just going to be a placeholder for now. I want it to be 200 dp with 100 dp also for the height. And I'm going to call this remote view. Let's use this. Okay. Let's say so the top should be to the bottom of this guy. Let's just constrain it this way.
Good afternoon, sir. We can't see your screen.
Are you kidding me? Okay. Sorry about that. Okay, sorry about that. You can see it now, right?
Yeah, yeah.
Okay. Well, interestingly, I've not really done something you can't pick up from. Just basically doing a layout setup, right? Okay, so um, I think I'm just going to copy these attributes here and add them here. Okay, so this is just going to be a placeholder. Okay, it's just going to be a placeholder. I'm going to use it later on, just for us to be able to see that. I'm going to just give a background. Do we have any default stuff I can use? Uh, okay, let's just use this. So we just get to see, what we have actually what done, right? Okay, so it's just going to be a placeholder. So this is where our, based on the um, design I showed you, right? This is where it's going to be, right? We can actually give more space, but we're not really focusing more on that. Okay, so that's basically that. Now let's go into the actual stuff, right? So remember those steps. So let's create our custom view what class. I'm going to create that class and I'm going to call it. I kind of want it to just rhyme with this in image view. So I'll call the class remote view. Remote view. Okay, so our class now should what extend the view class, right? So I'm just going to do this. So extends view class, right? But of course, you see we have this error here. So I'm just going to click on this. And then you can see it takes, we need to actually give it this what parameters. We need these parameters, right? We need this what parameters. So, but first of all, I'm going to choose this first one, add Android view constructors using at JM overloads, right? So, Android Studio will just add this constructor at JM overloads, right? It's just an annotation. And basically what it does is just tells Kotlin to the Kotlin compiler to generate overloads for this function that will substitute the default parameter values, right? Just gonna click that and kind of just helps me set up this for me, right? So our remote view, custom view is going to take a context, some attribute set, and the default style attribute, which is initialized to 0 by default first. So now, just above this my class view, right? I'm going to do some top level, enum. Of course, you know enum, right? So basically, I want you to represent the the our fan speeds are 1, 2, 3, and right. So of course you know that the enum actually is of type int because the values are string resources rather than actual string. So so this is what we're just going to do. We'll just fix it later. Let's just so I'm going to just have private enum class. I'm going to call it fan speed, right? And it should take a label of type int. So what do we want to have? We have off, and off should take r dot, and then I'm going to create this, right? I'm going to create these values. I'll create these values later. R dot string dot fan off. Okay, I'll create these values later, but I just want to list out a few things we're going to need. So um, low. So I'm going to say fan low, medium. I'm going to say fan medium. Well, let me just change this. So I turn off my caps lock. Okay, so fan medium and then fan high. Okay, and then I'll just end this with a semicolon. Oh, sorry. Let's end this with a semicolon. Okay, so we're going to create these, right? Because the reason that the enum actually is of type int, okay, is of type int because the values that we're giving here are string resources rather than actual string. So that's why we're seeing this error for missing string resources. We have not actually created them, but we'll do that later, right? But let's just set up a few things. So the next thing, I'm going to add some constants. I'm going to add some constants that we're going to need. And private, let's say const val, radius offset label. So I'll explain all this, right? Offset label. Let's just give it a default value of 30. And then I'm just going to duplicate this. And radius offset indication of minus 35. Okay. So then inside my remote view class, right, I'll define some variables that I'm actually going to need to draw the custom view. Okay, I'm going to define some variables I need now to draw the custom view. Now, one of those variables I need to draw, remember what we want to draw is like a circle, right? So one of the variables I need is a radius, right? I need a radius. Now, my radius, I'm going to give it 0.0 f. Sorry, hold on. Sorry. 0. What 0.0 f, small letter f rather. Okay, so this is going to be the radius of the circle. Now, another stuff I'm going to create is the fan speed, right? The fan speed. And I'm just going to extend my enum class. So I'm going to give it a fan speed. I'm going to give it like a default, right? And I'm going to set it to off. Okay, so more like a default active selection, right? The one that's active, and then okay, the next thing I'm going to create a um, position. Let's call it point position, and this is going to be of type point F. So this is from the graphics, the Android graphics library. So let me just finish that. Okay, so uh, this is going to be point F. So it takes in, the X and the Y parameters. So I'm going to say 0.0F, default 0.0F. Okay, so basically the radius, right? The radius is just the current radius of the circle, right? So this value, which is 0.0F, is set when the view is drawn on the screen. The fan speed is just, the current speed of the fan, which is one of the values from our what name what class, right? So the default is off. Now the point position is an XY what point. So that's what's going to be used to draw several of the views elements on the screen. Okay. So let's move on. So let's move on. So basically we're just going to create and initialize this here, right? So let's move on to something else. So the next thing we're going to do is to initialize a paint object. Okay, that's the next thing we're going to do. We're going to initialize a paint object. So what's a paint object basically? Probably let me just talk about it. So basically a paint object is actually a graphic tool in Android. It's basically used for drawing and styling graphics on a canvas, right? It's used to draw and style graphics on the canvas. Now, the paint class in Android just has properties and methods that will help you to define how you want to draw shapes, right? How you want to draw shapes, text, and some other graphical elements on your screen. So you can just think of the paint object as a set of instructions that tell the system how to render something, right? So it has properties and methods like color, stroke weight, style, text size, font typeface, and the likes. And like so, let's actually do that now. So let's initialize a paint object. So say private var paint. Okay. So I'm going to use this paint dot anti alias flag. Okay. I want to fetch the documentation if that can come up quickly. Okay. Okay. So this is what enabling this flag. So the paint flag that enables anti anti-aliasing when drawing. So you enable this flag, will cause all your draw operations that support it to basically just use it, right? So we're just going to set this, and then I'm going to use dot apply. So with that, I can now apply a style. So the style I want is paint dot style dot fill. I want it to be fill, right? The text align is the text align. I can still use my paint dot align dot center, right? Let's do a text size. Let's do a text size. Okay. This we can actually just kind of code that. It also have a property for the typeface, and then I'm going to say typeface. So I'm going to say typeface dot create, and then for now, let's just assume we don't have a name here. I'm just going to leave that empty for the typeface, right? But I want it to be bold. So whatever default typeface is to take, right? Just make it bold for me. right? Okay, so let's actually do something now. Okay, so let's just sort this guy out. So here for the fan off, remember it's enum, it takes an int. Um, so the value for the fan off, right, is going to be off. Um, the value for fan low is going to be 1. And the value for fan medium is going to be 2. And then the value for fan high is going to be 3. Okay, so yeah, I think we have that now, right? Okay, so now let's look into the concept of drawing the custom views, right? Now, the thing is, once you have created a custom view, you need to be able to draw it. We have created one. We've created a custom view called remote view. We've given it a radius, span speed, and every other thing, but you need to be able to draw it on the canvas. Now, when you extend a view class, a view subclass rather, such as your edit text, that subclass being the edit text defines the view's appearance and attributes and draws itself, right? So consequently, you basically don't have to draw, you don't have to write code to draw the view. You can just override methods of that parent to customize your view. But if you're creating your own view from scratch by extending the view class, which we're doing right now, you're responsible for drawing the entire view each time the screen refreshes. Okay, and they're also responsible for overriding the view methods that handle drawing. So in order to properly draw a custom view, you basically need to first of all, and let me just drop this as a comment here. You need to calculate the size, the view size, the size of the view when it first appears, right? And each time that view size changes, you need to calculate that. And we calculate that by using the onSize. We have the onSize changed method. So you have to calculate the size of the view when it first appears and every time it what changes. Okay. Now the second thing is you need to override the onDraw method, right? You need to override the onDraw method to draw your custom view using a canvas object that has been styled by the paint object. That's how we created this paint object now. Okay, then of course you have to now call the invalidate method when responding to a user click that changes how the view is drawn to invalidate the entire view. And invalidating the entire view means it is forcing a call to the onDraw method to redraw the view. Okay, so that's actually that. Okay, so basically the onDraw method that you need to note this, the onDraw method is called every time the screen refreshes. Every time the screen refreshes rather, the onDraw method is actually being what called. Okay, so and that can be many times in a second, right? So but for performance reasons and to avoid visual glitches, we need to do little work as possible in your onDraw, knowing that it is called a lot of times. So in particular, don't place allocations, right? We're going to just do that. You don't place allocations in your onDraw because allocations may lead to garbage collection and that will just make your visual. So don't allocate anything in your onDraw, right? So the canvas and the paint classes, that's basically what we're going to be using to, do our drawing, right? So we can draw a text using the draw text method, specify the typeface. It has a set typeface method and color. You can draw primitive shapes like rectangles with the draw. There's a method called draw rect, right? We have draw oval. We have draw arc, right? All these are methods, right? All these are methods to draw primitive or shapes. You can even change whether the shapes are filled or outlined by using the set style. Okay, you can also draw bitmaps, right? You can also draw bitmaps. You have the draw bitmap method. Okay, so Just one thing to note in applications that have deep view hierarchy, right? A deep view hierarchy, you can also override the onMeasure method that will accurately define how your custom view fits into that layout. Okay, so let's draw a custom view now and add it to the layout. So this is where it's going to get a bit it might get a bit confusing because you have to be looking at some mathematical stuff, right? We're looking at some mathematical stuff, but you get to pick up as we move. So let's draw that control line right now, okay, on our screen, right? So the first, so I'm going to go to so in our remote view class, right? Just below this, okay, here. So let's do something. I'm going to override the on size change. Remember what the on size change does, right? Is to calculate the size of the view when it first appears. Okay, so I'm going to override that. So this method is called every time. This was on override. So I'm just going to just type on size change. You can see that. Excuse me. So it's called anytime the view size was changes, including the very first time it is drawn when your layout is inflated. So we're going to override it so we calculate the position, the dimension, and any value at all that's related to the size of your view. So instead of recalculating them every time you draw, right? So in this case, that's why we're using the on size change, right? To calculate the current radius of that our circle what element, right? So I'm going to take out this thing and then return. So it takes, well, this WH, that's the width, right? I can actually change it to width, height, so you get to know what that actually does, right? This is the old width, and this is the old height. So that's what that actually means. So I'm just going to return the minimum, right? I want to return the minimum. So it will first of all get the minimum width and height, right? Need to import this. So that should be for the math. I hope I'm not. I hope I didn't import the wrong thing. Okay, don't worry. Let's finish up. So the width and the height, right? Divided by. I'm going to divide that by 2.0, and then multiply it by 0.8, and then um, you know, then convert to a float. Okay, so I think I probably required nothing, found float. So I think I'm using the wrong, hold on. This closes out there. So I'm probably using the wrong mean, right? So let's see. Let me clean out this. So you need to make sure we're using the right import. Import, uh, actually want to, should actually be, oh, yeah, it should actually be this. Okay, sorry, take out that equality and then, so return unit. So it's returning a unit, but what it found, it's supposed to return a unit, but what it's saying is a float. Okay, sorry. Why am I even, no wonder. So I'm not supposed to return anything, right? This doesn't have any return statement. So I'm just calculating the current radius, right? So what we do here is that we get the minimum, we calculate the minimum of this, right? Sorry. So it gets the current width, the current height, right? Gets the minimum, right? And then divides by 2.0 and then multiply by 0.8. Okay, so basically, yeah. Now another thing we're going to do is to we're going to create a function, right, to compute the x and the y for the speed, right? The okay, I think let me see if I can get. So let me get that image, right? Let me get the image so we can I can actually just show you while we are, um, um, let me just get that. So I'll show you while we are actually, still working on it. So you get to see, I can just back on it and then sorry, just a second. Let me bring this out. Okay, so let's see if I can just drop that in my drawable. Um, okay, let's save this image first. Sorry. Um, okay, so getting it now. Okay, it's that here. So let me just call it remote. Okay, so okay, good. So what I want to do is I want to create a function, right? I want to create a function that's going to, compute. That's going to basically just compute the speed, the x and y positions for this speed, the 0, the off, the 1, 2, 3, right? So I need to compute what that. Okay, so that's basically what we're going to do. So I'm going to create uh, more like an extension function, right? I'm going to create an extension function from our point f class. Okay, I want to believe you know what an extension function is. Okay, so basically an extension function. So let me see, private fun. So from our point f, we're going to use that to create an extension function. I'm going to call it compute xy for the speed. So it's an extension function. So I want it to take a position, and the position should be the fan speed of type fan speed. Remember our fan speed, which is this, and it should take the radius. Our radius should be of type what? Float. Okay. Okay. So let's do some things. I'm going to just set some angles, right? So you need to know that your angles are in radian. Let me just put that here so that when you get the code. So our start angle is going to be start angle. Let's get a variable. So it's going to be let's say math of pi, right? And then you know pi by 9 over 8.0. So these values, right, it's not like it's a compulsory value, right? It's just something, of course, dependent on where you want your position it to be. Sometimes you may have to try out and play around till you get what you want. Then I'm going to create an angle variable, and it's basically just going to be the start angle plus um, the position. We have what we call a position dot ordinal, right? So this is basically just return the ordinal of that your enumeration constant, right? So where the initial one is actually what 0. So the ordinal, and then we'll multiply it by math dot pi is 3.140 times let's see 4, right? We may have to adjust these things. So our x, right? Okay, so um radius times cos sine actually, right? So like I said, this is just going to be some mathematical stuff. and then need to import that. Uh, yeah, then you pass in the angle, double, right, and convert this to a float. Okay, so do that plus, and then we'll add our width. Just get the width, divide it by 2. This smart. Basically, going to use a sign, then the height instead of the width. Okay, so yeah, this is basically just computing for the speed, right? Then let's override the on draw. So we have the on draw here. So remember on draw, you're basically just drawing something on the canvas. So the on draw method renders the view on the screen with the canvas and the paint what classes. Okay, so I think we'll have to import the canvas. Okay, that has done that for us, right? Okay, so inside this method, right, before returning super.onDraw. So let's do this, right? So I'm going to set the paint color to gray. I want to use gray. I think that's basically what we have here. Okay, this seems like it's on already. So let's see when it's off now, it should be gray. So I'm going to just do this. So we've already created our paint object. So paint dot color, right? Now, I'm going to do this because what I want to set the background color, right, to green if the selection is not off. Okay, if the selection is not off, I want to set the background color to green. I want to set it to green. So how do we do that? So I'm just going to say if font speed, if the font speed, right, equal to font speed dot off, color should use color dot, should have gray, yeah, else, right, let the color be green. Right, so that's basically what we want to do, right? So we want to set the paint color to what? Gray, right? If the fan speed is off, right? So just take notes of that. So then let's move on. The next thing is to now draw this circle, right? Let's draw this circle. How do we now draw this circle, right? So we're going to use the draw circle method, right, from our canvas objects, right? So basically what that draw circle method does, it uses your current view width and height to find the center of the circle, right? Find the center of the circle, finds the radius of the circle, and then the current paint what color. Okay, so know that the width and the height properties are members of the view superclass. So you don't, so that's just something to note. So how do we do that, right? So let's draw the circle. I'll comment some of these things for you later. Um, how do we do? So I'm going to use my canvas objects dot draw circle, right? So, so what does it take? CX, CY, radius, and then the paint, right? So I'm going to give it, say a width divided by 2, convert that to floats. Very important. And then the height, I'm going to divide the height by 2, right? Convert that to a float. Okay. And then passing our radius that created, and then passing our what paint. Okay, so uh, just do this and we're fine. Okay, so that's basically that. So the next thing is we want to draw a smaller circle. This guy is small. This smaller circle for the indicator. For the indicator, so we want to just do that. So how do we actually do that? So what do we want to, let's say draw indicator. So so let's call it a marker. But we need to also calculate the radius, right? Okay, so it's just going to be our radius, right? Um, we created a radius offset with indication minus 35. So whatever we have, we're going to just subtract 35. Then our point position dot compute for x, y. Then I'm going to pass in our fan speed. Then pass in the marker radius. So this computes for, you are still going to use this formula, right? Still going to use these formulas for the listen indicator. And then what color do you want it to have? Paint dot color should be color dot black. Then the canvas okay, sorry, just give me a second. Okay, so now we can now draw a circle. Call our draw circle again, and then we pass in our point position, right? Dot x. So y, passing our radius, and then we can just divide our radius by, let's say, 12 or 10. Let's use 10 and see how it looks like, and then passing our paint. Okay, so yeah, that's actually that. So one more thing, we're going to now draw the labels, right? We need to also draw the labels, the off, 1, 2, and then 3. We need to also draw the labels at the appropriate what position, right? At the appropriate what position. We need to actually what do that. So um, let's do that. Yeah, actually have to draw text labels. Remember, we're building our custom view. Okay, so I'm just going to say label radius, right? Plus radius plus radius. So we're going to be using our offset label. So the offset should be about 30. So whatever the radius is plus what 30, right? So there we'll just do a for loop and then say for I in our fan speed, dot values, right? Okay. What do we want to do? The point position of that. Now we're using this function basically. We'll just pass in what I, and then pass in the label radius. Okay. And then we're going to create a label, and then sources dot get string. We want to get that string, where we have, and then I dot label, right? And then canvas dot draw text, and then we pass in the label, pass in our position, so the point position of x, passing the point position y, and of course also passing our what paint. Okay, and then of course our nullable distance. So that's actually that, right? So I'm gonna just take this top. Yeah. So that's basically what we have, right? Um, yeah, that's basically what we have. So yeah, I know it's been a long one with some confusing stuff, right? So let's add the view. We need to now add it to the layout, right? We need to add it to the layout. Okay, so I'm going to go back to my activity main, right? Then I'm going to change this image view to the my what remote view what class, right? Because you know, of course, your image view is also a class, right? So I'm going to change it, right? So remote, let's see that remote view. Then yeah. So another thing we're now going to do is, I'm just going to no need. I'm just going to take out this background. Go take out this background. Okay, so every other thing we can just leave that the way it is, right? Um, okay, so let's okay, I'm gonna run this on my physical device and then let's see. Sorry, I can't use my emulator right now, so um, hopefully this will actually be very fast and then I'll get to just share my screen. But if there are questions, I think I'll just entertain them now, right? While we wait for this to come up. So let me just run this.
Yeah, I have a question.
Yeah, sure.
Okay, so how, because you said the calculations that were done they are not kind of fixed. It is based on what you want. So,
Yeah.
and coming to the XML file now, it's not actually loading the view. So how do we know when we've gotten what we need? Do we need to keep on running the app to keep seeing the changes?
Yeah, well, yes, I would say yes, right? It all depends on a few. It depends on a few things, right? But I'd say yes. You can actually you just have to run it. But a lot of times, I think of the few times before now that I've had to do it, it actually shows it. So maybe there's a few things that I need to check out because it's basically just showing the class. So yeah, well, I'm just running it now. I actually get to see it, but my device now. I want to join with my, but yes, I can see it on my device, right? But let me let's see. Sometimes what I like to do is to refresh the layout if it persists. But hold on, let me just join so you guys get to see um you get to see it from my end, right? How it looks, and then we get to make whatever adjustments that we need to. make. So hold on. So this is what we have. Okay. You guys can hear me clearly, right? Hello?
Yes, I can.
Okay, sorry. Okay, so this is what we have, right? So it just means that we need to make some adjustments, right? We need to make some adjustments and let's see in some of our values. So let's get back to Android Studio. Let's get back to Android Studio. Okay, so um let's see. For Okay, so for the text labels, right? First of all, this from what we saw, that black indicator was just too close to the circle. So let me increase this. So let's say 12, right? And then just need to confirm our values. Okay, so offset label. So if it is compute with the label radius. So okay. So, well, like I said, this is a whole mathematics thing actually, right? So you need to be able to get the actual values for you to, for things to actually show up where they should actually show up, right? So, okay, so let me confirm. Okay, so top to this. Let me get our constraints. Okay. Okay. So we're good here. So I'll just test out that and then see what we should have. Of course, this is goal, right? This is where we're heading to in the end. And then from what we saw, we're only seeing the off, but we're not seeing for other values. So also need to check out these are drawing text labels to be sure that we are doing the right thing. So let's look at it. Right. So first of all, we said, we created that our label radius should be our radius plus the offset, right? And our offset radius label is 30. Okay, so then we are doing a loop to iterate through. So in the values of the fan speed, the position of each of them should be okay. So I don't think this is iterating as it should. It's like it's putting all of them in one position. Okay. Position X, position Y. Everything looks okay though. Draw a circle. So of course our circle is actually fine. We've worked on an indicator, so I think it's where we have a concern is the label radius. Okay. So let's actually see a few things. I kind of want to move on, but I want to sort that out. I'm still seeing even when I run it, everything is still put on the same spot. Everything is still put on the same spot. So we are not drawing our text labels correctly. So let me just play around. effect. So sometimes you just have to play around with the switch X or Y speed. And then here, so for, okay. Okay, so this doesn't change anything. Okay, I think I'll figure this out, right? So I guess there's something that is not, um, working the way it should. Something that is not working the way it actually should. Okay, but I'll fix that, right? I'll fix that. I'm sure it's just one thing I'm actually just missing out. But let's round that up. Let's round this up, right? So basically, what the last thing we just need to round up is to enable, an action. When you tap on it, right, to enable an action. That's basically what we need to do. So I'm going to create a function in our fan speed class, function called next, right? And the, this function is this. Look, when it switches the fan speed, right? When it is off, right? I'm going to assign what low. Um, let's just do this low, right? And then when it is low, I'm going to assign medium. When it is medium, then the next should be high. And when it is high, the next should be off. Okay, so that's just a next function, right? That's just a next function, right? So then how am I going to use it, right? How am I going to use it? So I'm just going to here, just before the whole on-site stuff, I'm going to create an init. I'm going to create an init and then add a property. It actually has an is clickable property. I'm going to set it to true, right? These are all properties of the view class, right? So we have access to it. Then I'm going to create a function, uh, basically override a function called perform click, right? And then what I want to do is if I'll just do a check if super dot perform click, right, return true, then I'm going to check update my fan speed dot next, and then just set a content description for the label. So I'm going to use resources dot get string and then fan speed dot label. And I'm going to call invalidates, right, and then return true. Okay, so this basically is going to help us, run the whole perform click. So this call to this super dot perform click, right? This actually must happen first because that's what enables accessibility events as well as calls to your set on click listener, right? So the other two lines, what this does is just it increments the speed of the fan, right? Or the most, yeah, let's say the fan with the next method. So and then sets the views content description to a string resource, right? Of that represents the current speed. So off 1, 2, or 3. The invalidate method basically just invalidates the entire view. So that's basically just forcing a call to the onDraw to what redraw the view, right? So if something in your custom view changes for any reason, including user interaction, and changes needs to be displayed, right? Then what we have to call invalidate what view. Okay. So let's see. I'm going to test this out. Think to so we'll probably finish up in our next class. Up in our next class. Okay, so let me finish this up, right? It has a class I need to attend to now. Let me share this screen. Okay. Okay, so after running that, so when I click on it, right, you can see it actually changes to green, meaning that it's no longer off, right? When I click on it again, it's still green. It's basically just going to low, but we're not getting that indication yet, right? So we'll fix that. I think we'll fix that in the next class. I click on it again, that means it's actually medium. Okay, so this is off, low, medium, high, off. You understand? So that's actually for the perform click, right? So what's gonna happen in our next class, right? We're going to finish it up because I want instead. So we need to display. We'll fix this. We need to also display the one, two, three. We also need to implement. When it is in one, it should have a different color. When it is in two, it has another color. When it is in three, it has another color, and so on and so forth. Okay, so we'll finish that up right in our next class, and but till then, I think this is just where I'm going to round it up.